Hi there, thanks for watching. This is Mr. Bowman, and in this video we're going to talk about arithmetic sequences. So before we talk about a specific type of sequence, we need to talk about what a sequence is. And in mathematics, a sequence is a function where the domain is the set of positive integers. We studied early in the school year just functions where the domain could be any set of real numbers. But for a sequence, the set of inputs is only the set of positive integers. Now we denote sequences with the notation a sub n, and that a sub n is similar to the function notation, f of x. So when I refer to a sub n, what I'm referring to is the output, or in other words, the term, the nth output value, or also the output value I get if I let n be that number. So if I have a sequence, and I said that a sub 4 was 12, then what I'd be telling you is that the fourth term in that sequence, 1, 2, 3, 4, is 12, and so forth. We often denote sequences by just listing their output values as a list separated by commas. So in a sequence that looks like this one, the first number, there'd be a number here of course, would be a sub 1. The second term would be a sub 2, the output when n is 2. Here's a sub 3, the output when n is 3, a sub 4, and so forth. What I'm showing you now is a great comparison between the functions we studied early in the school year that have f of x as their notations, where the input is x, and where any real number, or at least any subset of the real numbers, in the case of the function here, f of x is square root of x plus 1, are the inputs for the function. Here are their analogous sequences. Here's the sequence a sub n is n plus 2. Notice that the graphs look similar, except for that the only inputs are the positive integers. If you think about restricting the line we get when we graph f of x equals x plus 2 to only letting the inputs be 1, 2, 3, and 4, and so on, you just get a series of points. Here's another comparison between that function f of x is the square root of x plus 1 and a sub n equals the square root of n plus 1. You'd get the same kind of graph, you're just restricting the inputs to only the positive integers. So let's talk about arithmetic sequences. We say that a sequence is an arithmetic sequence. You know, the word arithmetic as an adjective is spelled exactly the same way as arithmetic, which makes me think of adding. And that's a great way to remember what it is. An arithmetic sequence is one in which the difference between consecutive terms is always the same. We call this difference the common difference, and we usually denote that common difference with the letter D. So these are all examples of arithmetic sequences. Here's the sequence 2, 6, 10, 14, 18. What's the common difference? What can you add from each previous term to get to the next one? It's 4. So for this arithmetic sequence, the common difference is 4. You know, for this sequence 11, 6, 1, negative 4, negative 9, you can't really add to get from term to next term. You have to subtract. You have to subtract 5 each time. Well, in this case, we can just say that D is a negative number. Is this last one arithmetic? I guess you could say it is, because you could add 0 each time. For the sequence 7, 7, 7, 7, 7, the common difference is 0. Now it's worth pointing out that for a sequence, the sequence goes on forever. The ... implies that this trend will continue. So here's a rule for finding the nth term of an arithmetic sequence. The nth term a sub n of an arithmetic sequence is a sub 1 plus n minus 1, that quantity, times d, the common difference. You don't necessarily need to memorize this, at least for our class. You may be required to when you use this in pre-calculus, college algebra, and if you study sequences beyond then. But let's practice with it today. Here's a quick example. Let's write a rule for the nth term of this arithmetic sequence. The sequence is 8, 15, 22, 29, 36, and so on. Okay, I made the rule magically appear there. So to write this, what do I need to know? I'm trying to find a sub n. I need to know the first term, and I need to know what that common difference is. Well, the first term in the sequence, a sub 1, is right here. It's 8. And what is that common difference? What is it that you can take each previous term and add to get the next term? What could you add to 8 to get 15? It's 7. And it works to get from 15 to 22, and 22 to 29, and so forth. D is 7. So all I need to do to find a rule for a sub n is to plug 8 in for a sub 1, 8 plus the quantity n minus 1 times d, which is 7. Now I would like you to simplify that. I think the simplest thing to do here is to distribute the 7 into both of these terms and get a sub n is 8 plus, 7 times n is 7n. 7 times negative 1 is negative 7. And like terms 8 and negative 7 will add to 1. How about 7n plus 1? I think that a sub n equals 7n plus 1 works. And a good thing to do would be to check that. For the first term, I should be able to let n be 1 and get 8. Well, if n is 1, 7 times 1 is 7, and 7 plus 1 is 8. Let's try it with like the fifth term here, 36. 1, 2, 3, 4, 5. The fifth term is 36. If I let n be 5, do I get 36? 7 times 5 is 35. Yeah, I do. So we've got it. Thanks for watching.